What are sunspots? Sunspots are places on the sun where some areas are a bit not as warm as others. So if I go up here, I have here a sun, and you could see through the filter that some areas are much brighter. That means that it's much hotter, maybe around 6,000 degrees. You have places where it's a much darker portions, and these may be 5,500 degrees Celsius or maybe 5,000 degrees Celsius. So it's not that those areas are cold, it's that they are not as hot. Keep in mind that the sun, if you look at this one, I'll make it a bit bigger, the sun, as its center, is very dense. It's very hot in the millions of degrees Celsius. And as you go towards the outer edge, then you have it's a fluid that is very hot, but it is moving very easily. So if you can think of the fact that if I love the analogy of a soup, if let's say that you have let's say a vegetable soup, you put it on the stove. When it's room temperature, it will have a flat surface. As you heat up, you're going to start, there will be some cells, some pieces will go up to the surface and other pieces will go down. So on the surface, it's uneven. It's always working through. Some bubbles are going up and other parts are going down. So that's exactly what's happening in the sun. And every so often, if the soup is too hot, what will happen is that you have little bubbles of gas that will go up, and then particles of soups and droplets will get off the pots. The sun, let's see how it works as well. So here you could see places where it's a bit hotter. You can see here where you have particles that are escaping the sun, the same way you'd have a droplet of soup leaving the pot. So if you go back to my example here, I have here my sun, and I have here areas which are much hotter. Let's see, 6,000 degrees Celsius. And these pieces here are cooler or not as hot. But this is creating a situation where there's a lot of action going on here. If it is even, then the energy coming out of the sun is even. If we have here uneven surface temperature, then a lot more things can happen. I have a little video here. There you go. So here's an example where you have the sun. See, it's very even to the upper part here. You have places here where right here you have a sunspot, cooler, and places all around that is much hotter. And what happens, you get fragments and particles going to space. You see a little flare happening right here. I also have a little videos here that are working well. And by the way, all of these links will be in the comments when I edit this video. Actually, when you look at this live, I did put all the links for you, but I just put it in the chat for you. So when you are looking at this one, you can see here that you have the sun. Here you have some sunspot, and here you have a flare. When you have a flare, particles, you have the wind, the solar wind, and particles going and affecting our magnetic field. And what happens, it plays, and when this changes in the magnetic field, that's when we have ions from the solar wind reacting with our magnetic field, and we have the auroras. So what's happening here is we have the sun that has activities on its surface. Interestingly enough, here it's all about temperature. So how did we discover that? So I was looking at some, let's see, where is it? Let's see, is it this one? Yeah. So I was looking at the history on when this all started. So it all started in 1600. So now, at the end of, early 1600, we discovered, or we created, the first telescope. So we had scientists looking at stars, and at some point, scientists says, okay, how about we look at the sun, the closest star? So we have four people they talk about. One is Fabricius, where we are recognizing him as noticing the first sunspots. We also mention Harriet in England. He seemed to be the first person who published the findings. So here we have Fabricius that seemed to have other things to do, and Harriet published it. We had Galileo from Italy that we learned about from school, and we also had Christoph Scheiner from Germany. But if you look at the drawing here, we can see that he had a drawing of the sun, and a drawing of the sun here, and you had places where it was darker. So this is this first idea of having sunspot on the surface. Interestingly enough, many scientists started to study those, and what they noticed is that between 1645 and 1715, there was a time when people were not noticing the sunspot. Now, the sunspots are important in many ways because the sunspots, when we observed them, we realized that we could see them they were moving from west here towards the east. And that's when we realized that the sun was actually rotating on itself. It's all part of getting to know our solar system, to go to the place where we thought that the earth was the center of the universe and everything orbiting around us, including the sun, to a place where we put the sun at the center of our solar system. So let's see if we can go back. So here we have a graph of their observations. So here, early 1600, they're looking at counting how many of those sunspots they could find. And here, for about 65 years, nothing. So what happened, they noticed at some point that early 1700, that a few started to appear, but you can see they were uneven. But then they realized that in 1750, then they started to be more predictable, because as they looked at their observations, they realized that their observation were able to be graphed and they were able to come up with information. And that brings us to the graph I'm going to show you right now. So if you look here, this is 20, so we are in 2024. Let's see if I can make it bigger for you. Like this. Nope, that's the biggest we can put. Okay. So here we are in 2024, and you could see here that this is the number of sunspots we can see, and they put it in between 100 and 150. They also show on the graph the number 25. And the reason for that is that since 1750, we are in the 25th cycle of sunspot. So let's see. I'm going to change the axis on the x-axis to add more years. And we have our cycle 25. In 1940, we were in cycle 17. And if I change it all the way to 1750, what we notice is that the sunspot, the number of sunspots, they reoccur in a cyclic way. So here the cycle are between, from what I read, between 7 and 11 years. So what happened is that you have an increase of sunspot to a time when there's no sunspot. So here you could see in between each of the cycle, no sunspots can be seen. So that means that the surface of the sun has an even temperature and not many things are happening. However, as you are getting in cycle, for example, cycle 19, when we have like 300 and let's see, 200, 300 here, so many more, that means that the surface of the sun had many more sunspots, creating a lot more activity, solar flares, and so on. So the reason why the eclipse happening right now on April 8th is that we are in 2024 where we're in a spot. Let's see if I can, there you go. We're in a spot where we have the 25th cycle. Let's go back to like this. We're right here, 25th cycle, and we're at the peak of the number of sunspots on the sun's surface. That's exciting because we will have an eclipse hiding the main bulk of the light from our sun, and we'll be able to see what is happening, what is being ejected from the sun at that point. And that's why so many people are excited about things we'll be able to study. How much action we can see at the eclipse, how much solar wind is coming our way, how much is this moon can stop the solar wind, how much our atmosphere will react. So many data that we just don't know what we'll discover. And that's why so many scientists are excited. Interestingly enough, if you look here, we have another graph. And the other graph here from the solar cycle, mentioned some radio waves coming our way. Now, the radio wave haven't been studied for that long, maybe since 2005. Let's see if I can go to 2005 like this. And I'm going to make this smaller for you. So there you go. So what we notice is that as the number of sunspots decreases, the less radio waves we are, the less energy wave we get from the sun. And here there's upper cycle here, and it's going down this way. So here we are in a situation where we have more radio flux coming our way, and the reason is we have more sunspots on the surface. So there's a correlation between the two. It's exciting for scientists, and some of you might be excited to study the sun, and just to show that it is an ongoing part. And if you've enjoyed the video so far, don't hesitate to subscribe to our channel. And I'm going to put here a video that I did not too long ago about the Parker probe that we're sending to study the sun. And you'll see the sun is exciting because this is a star, our closest star, and there's so much that we still don't know. So I know that we study stars from far away. We have the Hubble telescope, and then we came up with the James Webb Space Telescope, but we're still learning from our sun all the time. So if you enjoyed this video, don't forget to subscribe, and I'm going to put here, and actually I'm going to see you in a moment on this video about the Parker probe on how we are studying the sun. On this, I'll see you in this video.